Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. Coming up, a conversation with Robert Bean, a retired engineer, ASHRAE Fellow and distinguished lecturer, and co-host of the very popular Edifice Complex podcast. Robert is a well-known member of ASHRAE and has been an outstanding contributor to the organisation for decades. A fellow, a lecturer, a recipient of the Lou Flag Award and Distinguished Service Award, and active member of many standard committees over the years. But he is also very early to the table for advocating for a more rounded approach, a more human-centred approach to buildings, of indoor environmental quality in the round, and viewing buildings in the broader sense. In fact, he first came on my radar, as he probably did for a few of us, during the pandemic, through, strangely, his Twitter banner image. If you know, you know. And look, don't worry if you don't, we talk about it at the very beginning of the podcast. Indoor environmental quality is a broad church, complex and intertwined. And as such, this was a meandering conversation that I hope does it and Robert some justice. I hope you enjoyed the conversation as much as I did. Don't forget to check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Robert Bean. And ironically, like, I know you from your image on your Twitter handle was, I think, how most people got to know you as an indoor air quality or indoor environmental quality person, was that amazing human image with the different acoustics and vibrations and all of that. Where did that come from?
You know, it was funny. I was trying to find a way to illustrate that indoor environmental quality is not represented by air quality, right? Or that air quality is not a proxy for IEQ. And so I was just flipping through images one day, and there was this, like outline of a human. And I thought, well, I can take that image and I can draw in the sound and the thermal and vibration, and then let people understand that IEQ is a representation of all the sensory systems that the human body has been gifted. And that's where it came from. I said, well, let's use pictures.
So you actually sketched, that's actually your design then, is it? Yeah. Interesting.
Yeah. And we've just actually updated it because ASHRAE have added the microbiome and water quality to indoor environmental quality. And the water quality took me a little bit to sort of get my head around that, like why we would add that as an indoor environmental quality, but it actually is. And certainly the microbiome is.
Yeah.
And so I've actually updated that illustration. I haven't changed it yet on my LinkedIn profile, but in the upcoming ASHRAE website, and has anybody talked to you about what's happening with ASHRAE?
Oh, other than the kind of the move with the new chair towards a bit more of a health paradigm, I think.
Yeah. So coming up in June, our new incoming president, Bill McQuaid, his theme for the year is indoor environmental quality. And there's just a number of wonderful initiatives that are going to be launched. I mean, these are initiatives that started out, like, I guess, almost 2 years ago. And so what you're going to see in June is the launch of basically a 2-year project. One of that, which is a website. So much like how ASHRAE had a huge resource for COVID-19, SARS-CoV-2, we're now going to have a website, public accessible website on indoor environmental quality. And one of those will be thermal comfort. And within that will be the new illustration that we've been talking about.
Brilliant. Yeah, it always struck me that we could do more visually to represent this stuff. And I think I remember that image on Twitter, because it was kind of, it was doing the rounds, I suppose, at scale for the first time during the pandemic, wasn't it? When there was quite a bit of conversation about air quality. And I think a lot of people like me picked up on the image as being quite a powerful illustration. So
Yeah.
I suggest people have a look at all of that and maybe have a look at taking a run at doing some good graphics or imagery around indoor environmental quality, because it's certainly a theme of ASHRAE. It's absolutely a theme of the recast of the Energy Performance of Building directives. You know, putting the humans at the centre of the built environment, I think visually is a really interesting kind of idea. I think some graphic artists, not saying your image isn't great, Robert, but I bet there's some really talented visual graphics people that could do some amazing stuff with Aico.
Yeah, there was a company that actually, and I haven't followed them since I got off of Twitter, but they were, basically it was a recording of an artist doing pencil sketches of scientific concepts. And it was really well done. And I think he actually did, or she, I'm not sure who was holding the pencil, on filtration, I think. And it was something, anyways, it was in that world. But, they were hand drawing, humans and hand drawing particles and spaces. And so what you saw visually was the creation of these illustrations that really depicted the relationships that people have in spaces with the indoor environment, in this case, air quality and particles. So it was really well done. And it was it was what I would call very much at a street level or retail level. Like, it was easy for anybody to understand.
Well, I mean, it's a brilliant segue in some ways to really what was the first question I had for you, which was like, is there something about indoor environmental quality that can answer some of the questions we seem to have a problem with indoor air quality and connecting the dots? I've spoken to you about this before. Like, we seem to have this trouble reaching across the chasm of awareness, of people understanding the importance of air quality, of connecting the technical to the storytelling, to the relevance to people's life and health and well-being. Is there something in the broader scope of indoor environmental quality, do you think, that we can learn from and perhaps could help us unlock that challenge to some degree?
Well, it's a great question. And oftentimes when I receive these inquiries, I go to a continuum. My mind just sees this continuum, looking back into the 17 and the 1800s, where we were either making shit up or we are actually developing our hypothesis about what is actually going on. Well, in fact, the hypothesis goes back to Vitruvius's time, but where we are today and our ability to at least acknowledge that the neurosciences can unlock the answers to some of these problems, and that as we develop better neurological instruments to help us understand the brain and how the brain is the dashboard for what our body is experiencing. And that technology is there now. It's just really coarse. For example, the QEEG, and it's a qualitative electroencephalograms. I can never get that word right. Anyways, basically you put on a swimming cap, and the swimming cap has all of these probes that are actually measuring your brain activity. And they use it mainly in the health sciences, is actually where it got its sort of its basis. But the brain will respond to stress indicators. So we know that if there's a sound, like a loud noise, that the brain will respond to that. And we know that when the skin changes temperature, that the brain will light up in those areas where the sensory systems exist. And so, yeah, there'll come a time, hopefully within the next 50 years, that the neurosciences will become a big part of our understanding of indoor environmental quality. Because right now, we're basically dealing with architects and engineers and material scientists, and we have a pretty good idea about the mechanics of how things happen. But what we don't have is an understanding how physiologically and psychologically our bodies are responding to these things. like we use standards to create a benchmark, right? Saying, okay, well, if you meet this benchmark, then the probability of stress occurring is going to be lower than if you don't meet the benchmark. But our benchmark is based not on neurological sciences. It's based on people's feedback or studies, so which are all valid benchmarks, but they really don't truly tell us at a neurological level what's going on. And the more we understand neurological responses to the indoor environmental stressors, the better we can understand, well, what is actually what is a legitimate base level? Like how much lighting and how much noise pollution and the thermal issues and the air quality, like, where is actually that base level? Well, to do that, we're going to have to get basically normal brains and normal bodies, and then expose them to stress levels, either real stress levels or artificial stress levels, and then see what happens. And part of that actually goes back to the body goes between these terms called homeostasis and allostesia. And so homeostasis is the body's natural settling point, where everything around it doesn't require the body to do anything crazy, or even at above conscious level, we don't have to respond to something. So everything is fine, but we don't want environments so boring and so stale that the body doesn't get to experience changes. It actually likes that. And so that's what introduces that term allostesia, which is kind of like an exercising of your sensory systems. And it's a good way to think about that is that when you think about professional athletes, one of the reasons why they're so good at recovering of being out of balance and going back into balance is that that's part of their skill set, right? And so that is also can be applied to humans. When our sensory systems get out of balance, how do we get them back, or what is necessary to get them back so that we can experience being out of balance and in balance? And to give a sort of a practical example of that is if you're walking down the street, summertime, your MET rate is high, you're hot, you're sweaty, and then you enter an air-conditioned space. Well, there's automatically a sensory change that you go through, and in most often than not, that's a pleasant experience until it's not, because then at some point the space feels too cool, right, and too dry, and so that really understanding what is good stress and what is bad stress, or what is good balance and what is bad unbalance, is really where I think the future holds for us as far as IEQ goes.
Yeah, there's loads to unpack there. I think right back to the beginning of what you were saying, I thought was really interesting, and it kind of shows where we come from. At some point, that's all we had right was chuck 100 people in a room and tell them whether more than 80% of them were uncomfortable in that space for some reason. And hey presto, you got an ASHRAE standard out of it, and that kind of has held with us for quite. And sometimes is surprisingly accurate, as it turns out, as an assessment of general bioeffluent type comfort levels. But it's it only speaks to the masses, to the on average, to the typical person, to the 80th percentile, that kind of language. It doesn't speak to the experience of an individual space. And I think, the one that pops out straight away there is things like thermal comfort. We can determine bandwidths for things like thermal comfort, but your comfort and my comfort are going to be two very different things. I was in France last week, and it was fairly uncomfortable for me, being from Ireland. I mean, in Ireland, the melting point of the Irish, I think, is about 26 degrees. So stick us in 28, 30 degrees and life gets pretty challenging for us quite quickly. The difference between myself and my wife, what we find comfortable is very different. So the experience at an individual level to things like indoor environmental quality can be very complex, can't it, as a whole? Yet speaks to, in some way, the individual's experience of that space better than just your exposure to some threshold of benzene or something,
Yeah, and why that's important is that we're not going to be able to make everybody happy all the time in all of the sensory systems that we have. Like, that's asking too much. But currently, we don't even recognize that occupants are the most important part of the building. So we have had, and it is changing, an architectural ethos that is more about the ego of the design of the building rather than what is the building actually doing. And it's housing people. And there's a really sort of one-dimensional recognition that, we should, have some ventilation in the building, and lighting should be, not too bright, not too dark. And, the thermostat should read whatever, pick a value, 22 degrees C. But that is so coarse, compared to our understanding of how people actually experience the space. And until architecture represents what people actually experience, we're going to have these battles that we have. And part of that is it's a cultural thing, it's a business, it's a property development thing, which is highly business, profit related. And it's also a building code issue. Like, it's not one thing. That's the challenge that we have. When I got out of school, high school, actually, one of the first jobs I had was working for a geotechnical engineering company. And my job was to do analysis, for example, for aggregate. And so if the aggregate was being used, say, for example, in a concrete mix or asphalt mix, we had to do an assessment of what percentage of the total mix were different grades, ultra fines, fines, till you get down to the bottom. And these were basically cake pans, that had mesh. And of course, it allowed the coarse stuff could get down to the very top, or the fines got down to the bottom, and the coarse stuff was at the top. Well, each one of those cake pans, if you will, represent the roadblocks that we have to getting the knowledge that we have scientifically down to the consumer level. You've got a cake pan that represents codes. You got a cake pan that represents architecture. You got one that represents engineering. You got one that represents material sciences. And, there's like 12 levels that information needs to pass through. Well, by the time, if those filters get plugged, codes, for example, is one of the roadblocks preventing information to get through to occupants. I mean, if the codes today, if we could convince code authorities to let indoor environmental quality voices run the code meetings and to produce a code document that represented that voice, we'd have completely different architecture today.
Yeah.
Like, there's, because we would address things like, outsourcing, which is in every ventilation standard that I know of, but nobody does outsourcing, or source control analysis. Yet there are software tools that can tell us that if you put in a certain carpet or engineered wood flooring, right, and if you expose it to temperatures or moisture, we know what the outgassing of those chemicals are. Like, we can make the souffle, the list of all of the ingredients, and we can watch the decay rate. Well, that's what source control is all about. But nobody does that. It's not. Yeah. I mean, it is a science, and you have to understand that there's a relationship between the environment and the materials that we build spaces with. But it's not so out there that it's not possible. We can do this stuff, but nobody does it.
So to set some kind of boundary conditions to the conversation, then, Robert, if someone's asking you, what do you mean indoor environmental quality? What's the 101? Like, in broad terms, when we're trying to describe indoor environmental quality, what does that mean to your mind?
First things first is that it's a human experience. It's what we feel and what we see and what we hear. Even, as soon as an infant can start to communicate, they can tell us the vision that they see, they can tell us the sounds, they can tell us the thermal. Little children, like my granddaughter, when she's cold, she can tell me that she's cold. So you think about the vernacular words that people use to describe the places that they're in. It's cold, it's drafty, it's loud, it stinks, it's muggy, you know? And that, to me, is sort of where it's about the human experience. And we can get all fancy with technical terms, but the reality is that, you know, a 3-year-old can tell us what the environment is about. We don't need to have a PhD, right?
Yeah.
So indoor environmental quality it's a human experience, and they are gifts. You know, it doesn't matter whether you're in Bangalore or you're in Fairbanks, Alaska, or you're in Jakarta. You know, everybody, you know, if you're relatively healthy and have been born with the normal DNA of the human structure, these sensory systems are gifts. They're the input values to what's going on around us, and our brains and bodies respond to them.
Yeah.
You know,
but I think people can instinctively understand the extremes of the spectrum here. You know, like people know when they're uncomfortably hot or cold. Mm-hmm. People have an understanding, particularly if they come from a space of reasonable outdoor air into a stuffy space. They'll have a perception that it's poor air quality.
Yeah.
They'll recognize poor acoustics in a space, either high levels of background noise or reverberation or difficulty hearing somebody clearly, those kind of things that cause stress and tiredness because of the acoustics. So some of this is quite visceral in its experience. We understand the human body will recognize when we're in spaces like that. But the challenge here is that what we're often talking about isn't the extremes. We're talking about optimal conditions that enable us to do our jobs better, that aren't causing us migraines and headaches or sick building syndrome or lack of attention or cognitive impairment or whatever it is. And some of that stuff isn't experienced. So you were talking about the mental states. A lot of the spaces within the building that are detrimental operate in that zone where there isn't a human reaction to it. So vibration would be a good example of that. There may be states of vibration that are very difficult to perceive, but are nonetheless causing a stressor on the body. Acoustics is a classic one. You know, you can be in environments where you don't notice it's bad until you're in a place that isn't, and you go back into it and you go, gee, that's hard work in here, you know? Yeah. So some of this stuff's really subtle, isn't it? So how do we start to create the building blocks to define that? I think people listening to the ventilation and air quality one, it can be slightly different in that space because there can be toxicological impacts of being exposed to benzene or formaldehyde, right? There isn't a toxicological impact to being exposed to light flicker or the poor acoustics. So it's a different thing, isn't it? In some parts of the indoor environmental, it's subtle, it's nuanced, it has impacts on health and well-being, but not necessarily an epidemiological or a toxicological reaction.
Right.
You know, so it's a complex world in that sense.
Yeah, and it's funny because in our Edifice Complex podcast, you know, part of the outcome of that is to inspire students, STEM students, because I can't think of another field of study, you know, that challenges our knowledge of engineering principles, architectural principles, and health principles than the indoor environment. You know, it's for exactly the reasons you just said, Simon. It's like there's just so many interesting aspects, and some of them are quite clear and some of them aren't, you know, and like even within air quality, right? When you think, like oftentimes I find myself debating with indoor air quality experts about separating out odors, you know, as a separate subject matter. And the reason, and my logic on that is that not all odors have a consequence to them, you know. And I think, like, for example, food preparation, they're cultural based, right? So if you bring a culture from one country to another and you introduce the odors of that culture to, you know, the recipient, well, they can find it offensive, but it may not have actually a physiological or psychological or epidemiological impact. Like a toxic, there's nothing toxic about it, right? And
Yeah.
but there's some things that don't have odors, like radon, for example, right, or carbon monoxide, and our bodies don't have those gifts. So that's like, those are just two really small examples, that make it such an interesting study.
Yeah. I think that's what I was going to ask you about odors, actually. I wonder if it should be its own indoor environmental category, in the sense that it has, I mean, how many of us say that it's odors that trigger a memory or
Absolutely.
a physiological reaction through memory, but stronger than almost any other sense that we have.
Yeah,
Even
totally.
down to a smell of a book will transport you back to being 4 years old, like that. And if that's a good isn't it amazing?
It is. It's a great discussion. And, as soon as you're born, in fact, the study is ongoing. I mean, it's one of those areas of study, the olfactory systems, how the chemicals that trigger the neurological response in our olfactory system that then become memorized, and that experience of smelling vanilla for the first time, right? So there was a certain combination of chemicals that your brain recognizes or didn't recognize at the time, but now it triggers it, right? It's an experience, the vanilla experience, and it resides in your brain as a memory experience, right? And you can go through all the things the smells that you recognize, and they sit inside your head as like a library of odors that you recognize. And when you don't recognize an odor, like for the first time, you start doing mental exercise. Like, what is that smell? Like food sometimes will do that, right? With herbs and spices and different things. And you'll try something for the first time. And then of course you'll try to say, okay, it's not quite, rosemary, but maybe it's something else. Right. Yeah. And so, I love that study. If I had another career, I probably would go back into that area. And Olfactory, actually, Dr. Olfactory, I mean, he was the guy that coined the term the Olf, the unit. And that was his way of how do we put units to the olfactory experience that people have. And so if anybody wants to study the origins, modern day origins, it was Olfactory.
Yeah,
he's known for thermal comfort, right? But he did a lot in air quality. And
Pavel Argoki, who's been on this show a couple of times, he studied under Ollie, obviously, and in DTU, and a great history there of studying into it. In fact, I was in the DTU labs, and they've got one of the oldest atmospheric chambers in the world there. In fact, I think they're still using it, and it was built 2 years before I was born. And it's still functioning today as a really good, and I'm not old, 50 years old, but it's just goes to show how old some of the science is, like what we'd consider modern. I suppose the interesting thing, like I'm torn, right? There's two parts to this. I can clearly see, because I'm a storyteller, I'm a communicator, the value of putting humans in the center of buildings. Because ultimately we build buildings for people, and our experience of those spaces, both how they make us feel and their impact on our health and well-being, are the reason we build them, ultimately.
Mm-hmm. Yeah, absolutely.
But also at the other side of this, as we've kind of attested in our first kind of waffle over the last 20 minutes, has been how complex indoor environmental quality is. And from an outcomes perspective, it's hard enough trying to join the dots between something as obvious as radon and people doing something about spaces. Like I often joke, it's the slam dunkiest of pollutants, because it only comes from one source. We've got a straight line between it and health impacts. We know how to measure it. It's cheap to do it. We can fix it largely. It should be the no-brainiest of no-brainers in the air quality world. Yet we seem to struggle with even that one.
Oh my God, it's like it's
You
not
know,
even just within the subject itself. It's actually countrywide. Like
yeah.
like I remember
So,
in 1980, it would have been like 1985. I remember there was a company that was making heat recovery ventilators, air-to-air heat exchangers in Canada, and they were marketing them as solutions for radon, for ventilating the home. That was in 1980, 1985 or 87, something like that. Well, for God's sakes, the Canadian government it's like recently that they said, oh, well, maybe we have a problem here. Like it's like within the last 10 years. Health Canada issued a bulletin, and that they've been doing research work across Canada. They've identified hotspots where radon exceeds recommended health levels, and that if you're in one of those areas, that you should look at putting in passive, and if it's aggressive, then active systems. Well, we knew that for like, why did it take our federal government and the Canadian Health Institute, 20, 30 years after we already knew that there was a problem to respond?
yeah. So actually, I was at a conference there recently, and the Canadian Radon group were there. I can't remember what the National Laboratory Standards Authority is in Canada, but there's a radon group there.
Yeah.
And they were saying that for years they've had a standard in Canada where new homes are built with a sump and a radon barrier, and they have a couple of foot of pipe that you're supposed to cap in buildings, so that if there's radon found, you've got something that you can then extend to atmosphere and so on. And then what they're finding is a lot of the times these things are left uncapped, or somebody doesn't know what it is. It's supposed to be labelled, and something, they put a soil pipe in there or something stupid. You know what construction's like. But basically, it just turns into a radon chimney in a lot of people's homes. So, like, the unintended consequence of this approach has been, because in Ireland we have a sump, and it's to it goes to the outside perimeter of the building as part of the regulations. But in Canada, I think because of the temperature and the temperatures you can get outside, it has to be terminated within the thermal envelope. But it should be capped. But if it isn't for whatever reason, or that malfunctions, you basically end up with a radon chimney straight into the property, which is just bananas.
Yeah, it is insane. And we're certainly not laughing at the consequences of radon. We're laughing at the fact that something that we know about and is really simple to solve. It's not a huge expense. You're talking PVC pipe, and it's just like,
yeah, it's mental. But I've had this conversation a few times. I don't know if there's something about radon, or if it's indicative of indoor environmental quality in general. But like worldwide, you can't give a radon test away. People don't want to know. So whenever they go and do these national studies and things, often there'll be funding to give free radon tests to areas where there's high levels of radon. And the take-up rate is like in the low teens. Like you get a knock at the door, or a letter through going, oh, by the way, your home is potentially in a high radon area. Sign up here for a free radon test. And people go, no, thanks. I'd rather not know, la, 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 So there's something odd in the human psyche that says, I'd just rather not know. Thanks very much.
Yeah, it's like, I think the statistic is in many countries, radon and its relationship to lung cancer, it's the second leading cause. And I think if you have high exposure, sustained exposure to radon, and you're a smoker, you're pretty much guaranteed of getting lung cancer. Right. Well,
yeah, the multiplier factors for smokers and radon, I think, is horrible.
It's terrible.
I think smoking is, surprise, the number one way you expose yourself to nasties. But if you're a smoker and you've got radon in the property, good luck. From a lung cancer perspective.
Yeah. So these people that go la 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 la, I don't want to hear about it. I suppose if smoking had no odor, going back to odors, but it caused lung cancer, people would say, well, yeah, I don't smell it, so it's not a problem.
Yeah. I was a housing officer was talking to me the other day. He went out to do a ventilation inspection, and the homeowner was walking around the house smoking. They've actually got a policy in the housing authority now that workers aren't allowed in houses where they're smoking. unless windows are open, because it's an occupational risk for them if
Oh,
they're going in
yeah,
and out
sure.
the whole time.
Sure.
I hadn't thought of that, but it's a fair point. But he was laughing because this guy was walking around showing him small spots of mold and damp on window reveals and stuff. So saying, look how terrible the ventilation is. And the guy's like wafting the tobacco smoke out the way to look at the mold, pointing at the mold. And he's like going, you know, from a risk assessment perspective, the guy had it complete arse about face. You know, he was really, really concerned about his family's health because of this, because of the risk of damp and mold in his property. And you bet you could barely see the mold through the smoke.
Yeah. You know? Some of the extreme examples of that too. I mean, that's a great example. But a colleague of ours in the industry got called out to a home that had it was a mold issue that had gone beyond. I mean, it was crawling up the walls and in the ceilings and every nook and cranny of the house. And then it was the woman that had a small infant, and the physicians had told her, you know, because of her respiratory issues, to keep the moisture up in the house. But no one said, well, can the house actually handle a higher moisture content? And it couldn't. It just the age of the house and the ventilation of the house, it could not sustain a higher moisture content without causing, you know, or enabling mold to proliferate. And so the woman thought that she was doing the best thing that she could for her child because of the advice of the physician. And it didn't matter what you said to her about the consequences of such an action, you know, it didn't matter to her. And yet she was actually making it worse.
Yeah, amazing.
And so there's a huge disconnect. And it's unfortunate because both the health sciences and the building sciences, we have a common denominator. It is the occupant. You know, and if there was ever a worldwide example of cognitive dissonance and disconnect between two sciences, it was during COVID. I mean, and we still have it. You know, despite the World Health Organization finally recognizing that airborne particles can be the host for pathogens, we still have people, experts, that will deny that. They just cannot get that. It's so dogma for them that they can't break their thoughts. You know, I posted on LinkedIn here recently. I was watching actually the release. We have willows and poplar trees here, and this is the time of year that they pollinate, that they release into the atmosphere, and it's, you know, it goes on for days, and you can visually see particle flows, and there's engineering science that can describe the aerodynamics of particles in spaces. And I think my post was, today for a few minutes, I pretended that I had a PhD in the public health sciences, and I was able to completely deny the airborne nature of particles. And what would that have been like to be so naive with such a high level of education? And I couldn't. My brain was about to explode. Like, I couldn't be in that world.
It was Joseph Allen was on the podcast there a few weeks back, and he was saying it wasn't until that image of the tobacco smoke during COVID, I think it appeared on Twitter at some point, that suddenly it started to resonate with people that these particles could float in the air like smoke in the air from one side of the room to the other. And, you know, you didn't have to see it, but you could smell it. You knew it was there. And I think those mental leaps, those visual frames that connect those dots are incredibly powerful. And perhaps that is one of the potentials that indoor environmental quality has, is that it puts the human at the center, that it potentially is the point of contact between sciences, that rather than just talk, you know, rather than missing the boat with a whole branch of medical sciences because we're just talking about the impacts of particulate matter or formaldehyde, or however excited I get about those things and scream how important they are, that there are so many other things that impact people's experience of the space, but particularly thermal comfort, cold and heat, stress, and these kind of things, that maybe we haven't been able to connect with the medical community in the way that we should have done, and maybe indoor environmental quality could be one of those keys to do that, perhaps.
Yeah, if you go over the last 3 decades, there have been conferences where the health sciences and the building sciences have come together under a common roof and discussed, the common denominator, which is the occupant, as it relates to the building and the health sciences. So there's been, at least in Canada, there was one that was done, and then there was another one in the United States, and the conference papers were published, but at the time, it was the U.S. Surgeon General, I think it was, who happened to be an ASHRAE member, an ASHRAE Fellow, and he may have actually also been a professional engineer, wrote about how architects and engineers and interior designers and decorators, we may as well throw them in, but it's a separate field from interior designers, don't study human physiology and psychology as it relates to the built environment. It's just not part of the curriculum. Likewise, physicians don't study architectural and engineering subject matters. But between the two sciences, we have this occupant that's exposed to the environments and they respond to it. Air quality is an easy one because we know that there's respiratory response systems. But the ones that are more harder to define are lighting and sound and thermal and vibration and odors. That's why we talked earlier about the neurological sciences, because you can't deny through looking at brain imaging what is actually the brain is actually responding. You can actually see it,
Yeah.
So
yeah, and as an acoustician pointed out to me earlier in the year, if you think you're unheard in air quality, you should try being an acoustician.
Yeah.
But, you think you've got it tough, try being in lighting or acoustics or, God help, vibration or something, good luck getting a sounding board.
Yeah. And to many, the sound is to some degree a consequence of solving indoor air quality problems. When we started to move towards more natural, harder materials, exposed concrete, glass, steel, woods, and we removed the fabrics because of the synthetic components, the benzene, the toluene, the formaldehydes. We wanted to get that out of the indoor space to solve the air quality problems. And in doing so, we went to more natural materials with less toxicity. But in the process, we've created sound problems. Because these concrete... Yeah, we create these echo chambers, right?
Yeah, and again, he was explaining to me, and I'll probably do him a massive disservice, but a guy called Jack Harvey Clark, he's worth checking out for people that are interested in acoustics. But it's like the second leading impact on health and well-being, acoustics, behind air quality. It's hugely important to our long-term health and well-being, but it's a really complex one. There are not only physiological impacts of sound on human health, but there's also a massive impact on what he'd call the annoyance of it. So that your feeling of control, agency, all of these things have huge impacts on your experience of the environment and profound impacts on your long-term health and well-being, as an example. So, small things like, even though the sound might be the same in a poorly and well insulated space, your ability to open windows from the perspective of air quality and control the sound as part of that will have a huge impact on your long-term health and well-being. Like the sound of an urban environment outside might be no different between one building and another, but your agency to control that with openable windows, for example, if your only way of controlling ventilation in the space is an openable window, and you're exposing yourself to what you see as the burden of urban noise, that has a long-term impact on, because with annoyance comes stress. And as we know, anybody understands stress, long-term exposure, even to low levels of stress, have a stressor on the body over time that impacts
They totally
health.
do. The Academy for Neurosciences for Architecture is an awesome resource in this discussion, because there was and I apologize to the physician that wrote the book, Elizabeth. Anyway, she wrote a book called Healing Spaces, And it had to do with the study of people healing in different environments. And one of the studies that they did that she wrote about was two groups that were recovering from the same surgical procedure or some other kind of exposure to some kind of illness. And the data set was broken into two. So one group was exposed to the natural elements. So in fact, they were able to open up the windows, but it wasn't, a streetscape that they opened it up to. It was a park where there was waterfalls and birds, and you can hear the trees rustling, and you could actually physically experience the changes in the outdoor environment. So when humidity went up, they could sense that, right? And the other group were stuck inside in a sealed room that was naturally or mechanically ventilated, and there was no view. The view was either a brick wall from the building next door to it, bad lighting. Anyways, the message there is that those that were exposed to the natural, stress-free sort of environments that we covet healed at a much faster rate than the other individuals. You know, and it's so we know that connection, but the challenge also is that in today's world, where population growth is putting stress on our indoor environment and the spaces that we occupy. And it's not, and so when I hear people talk about like natural ventilation, for example, and I go, yeah, okay, fine, great. I'm all for natural ventilation. But where is that building located? And what will be around that building in the future? Because if we allow sprawl to occur around that building that's designed for natural ventilation, well, soon there'll be streets. So now we got traffic, and then of course there'll be people. So now we have security issues, so we have, and then as we start to introduce more people and new vehicle traffic and other industries, now we have air quality issues. So opening up the window sounds like a great solution, and it is in some cases, but for how long, right? And when I think about like Vancouver in Canada, right, like those buildings, a lot of those buildings, and maybe people aren't aware of this, but 2 years ago, over 600 people died in Vancouver due to heat stress. There was a spike in temperatures, and those buildings weren't mechanically cooled, and their only connection to the outside world was through an open window. Well, if the temperature goes up and the noise is there and there's a security issue, you keep the windows closed. Well, if the building was never designed to deal with those heat loads, then the temperature increases. The mean radiant temperature goes up. All the surface temperatures go up. The body can't discharge its energy to these surfaces, so the body retains the heat. Your temperature body rises, and now you're in a heat stress mode. So architecture and engineering is not easy. But we have to, but the problem we have, Simon, is that our education systems and the way we practice basically has boundaries on it. We've not taught the practice to understand that, again, going on to a continuum and see things three-dimensionally and try to understand the long-term consequences of the decisions that we make today. And now you're getting me onto some of my soapboxes, but one of them has to do with housing. Oftentimes I ask in my classes, like, how many people here want to die in an institution, even a modern institution, which is designed to all of modern standards? How many people want to die in an institution? Maybe less than 0.5% of people say, yeah, okay, I don't want to die at home. I want to die in an institution, right? Everybody else wants to die at home. Well, if you think about the environments that we create in modern hospitals, where lighting is actually looked at and sound is looked at and thermal comfort, everything is looked at, even to the extent that when you look at ceilings, there's murals on the ceiling so that when you're on a gurney, you can look up and you're not looking at a suspended ceiling tile, right? Like there's an engagement with the patient's physiological and psychological experience with that environment that's all about healing. But that philosophy doesn't exist in homes, and yet homes ultimately become an extension of the institutional healthcare system. People want to die at home, but nobody talks about the ventilation you're going to need when you're 85 years old and your ability to maintain good hygiene in the space is gone, right? Or if you require special medical equipment that we need to create environments so that these instruments and machines can function the way they're supposed to function. Nobody thinks about that. But that's what happens.
I'll have you back to the podcast in just a minute. but I wanted to tell you briefly about Imbiot, a partner of the podcast. I came across Imbiot a while ago, and in fact, completely unrelated to the podcast, had been trying out some of their sensors here in my office, which I still have here today, and with customers. I was seriously impressed then and remain so. Imbiot are a multidisciplinary team with a common goal to promote healthy and sustainable interior spaces. They manufacture smart indoor air quality monitors and an exceptional cloud platform. Look, I get to see and use many products, as you could imagine, and Imbiot stands out here. The quality of the product, the innovation they bring with sensors and connectivity options, and a platform with some unique approaches to reporting and integration with many of the reference standards in the sector like Reset, Well, Lead and others. Their devices can also be integrated to any building to control and automate the operation of HVAC systems, ensuring optimal air quality and energy savings. Details are in the show notes as always, and at airqualitymatters.net and at Imbiot. That's INBIOT.ES. Now, back to the podcast. I suppose in a lot of standards, we start to think about homes from an accessibility perspective, so having wheelchair access and spaces that can be converted into bedrooms downstairs. And, you start to see that happening in modern design, but you're absolutely right. The design for indoor environmental quality, and we've had a couple of conversations on this podcast and more broadly around that. Tell me why your symptoms aren't a good. Tell me why your home isn't a good story for the symptoms that are presenting to me. Well before you're in your terminal phase of your life, your home can become the place that, let's face it, you're kicked out of hospital pretty rapid these days back to your home environment, and it can become a cyclical event. The space
totally.
That's causing the conditions that is hospitalizing you is the very place you get sent back to early to be readmitted, only for the same things to be reoccurring. And we wonder why we end up in this eternal loop of COPD patients, cardiovascular patients, and so on and so forth.
Yeah,
in this
it's
eternal
terrible.
cycle.
Yeah, it's terrible. I mean, and so there's a whole field within the world of architecture and interior design, lifetime housing, right? But that has to do, as you pointed out, more with the geometry of the spaces and accessibility. But indoor environmental quality is an accessibility issue. Like, we can't ignore it. And I think like for your listeners, just pretend that you're 80 years old, you have lost, there's a high probability at 80 years old, your physical abilities, your visual acuity, your cognitive abilities are all reduced. And, adaptive comfort, for example, becomes incredibly difficult for somebody who has arthritis, severe arthritis or Parkinson's or, some other ailment. And, and this message is for manufacturers of thermostats, for example. Like, if you're 80 years old and you're trying to adjust your thermostat and it's a poorly lit device, the numbers are small, the manual is probably 27 pages in a number 6 font, shame on you. Shame on you. These manufacturers that hire industrial design firms, right? People to design the ergonomics of the product. What they need to do is do focus groups, much like IDEA does, who's a well-known industrial design firm, but they bring people in from all over to design products. Like, when you think about the mouse, right? How did the ergonomics of the mouse occur? Well, you have to bring multiple people in. You have to understand human physiology and how does it work and what makes this thing move. Well, that required more than just, a physician, right? It had to be. So yeah. If you're a manufacturer of instruments that are the interface between the occupant and the lighting systems, the mechanical systems, hire 80-year-olds, because those will be the ones that ultimately have to use your device. It's not the 20-year-olds or the 30-year-olds that have a problem with it.
Yeah, and the interesting thing about accessibility, and Plumstone puts this really well from the Safer Air Project, when we think about accessibility in spaces, we're automatically thinking about, hearing impairment, vision impairment, wheelchair access, those kind of things. And there's a kind of cognitive dissonance to those situations because only a very small percentage of us are going to end up in a wheelchair or, physically disabled severely enough that accessibility becomes an issue in spaces. But when we're talking about other risks, like risks to infection, for example, how many of us, what percentage of us are going to end up with cancer before we die, right? Now, when you're on cancer, you're going to be put on medication that's going to severely reduce your immune system. And now all of a sudden, you're heavily reliant on indoor environments to protect you from infection risk. Now, all of a sudden, accessibility becomes a real issue in a lot of spaces because of risk of infection and poor indoor air quality. So there are all sorts of ailments and illnesses that can that can affect all of us, every member of our family. So we're only ever a heartbeat away from our indoor environments being
totally true.
Absolutely critical from an accessibility perspective. And there are whole swathes of the population who can't go into banks and classrooms and libraries and public spaces and so on because of all sorts of different risks. And we don't realize it, I think. And the co-benefits can be enormous for getting those spaces right. The best analogy for that, I think, is the wheelchair one, actually. The co-benefit of providing wheelchair access in public spaces is that mothers with pushchairs and people that are a bit dodgy on their feet and all of these benefits of accessing spaces more easily provide and lifts in spaces and so on. I'm in my 50 and got bad knees. I appreciate a lift here and there these days, never mind anybody else. But the same with air quality. If we provide decent indoor environments for people, the co-benefits are enormous for everybody else as well.
Oh, absolutely. And that I remember getting into debates, in our classes with individuals, and I said, show me a person that when they were born, that in their operating manual it said, you're not going to die until you're 95 and you will be in perfect health when you do. And show me a person that's got that card. You don't know. Right? I mean, we know statistically some individuals, because of their DNA, have a higher probability of developing cancer, for example, or Parkinson's disease, Raynaud's disease. Let's just go through the list. But you don't know at all what could happen to you. Maybe you get into a vehicle accident. Well, how do you so now you're a paraplegic, or even worse, a quadriplegic. And now what do you do? Or something else happens to you where there's a physical attack on your body, and now all of a sudden you're in a space that can't serve your needs. You don't know, right? And so my argument was, if we don't know, then we ought to, much like the precautionary principle, if we don't know, then we ought to resolve it before it happens, if it does happen. And when I think about ventilation is a great example, and I'm not sure what level of language we can use on your show here.
Whatever you like.
It pisses me off when I hear people in standards committee meetings trying to reduce or simplify or lower the cost of ventilation systems to a lowest common code denominator, when they have failed to understand that the ventilation system in that space is going to be operated by somebody 50 years ago or 50 years in the future or 60 years in the future that is not represented by the ventilation rate that system was originally installed for. So you have to anticipate that. Let's take a home, for example. A new home, there's a high probability, in a mass-produced residential, where there's thousands of houses, right? They're going to be young families moving into there, right? And so we can assume that most of them will be able-bodied and they're able to adapt to their environments, and they have all of that, right? But 100 years from now, if those buildings are built right, they'll still exist, but those won't be, 20 20-year-olds buying those houses or 30-year-olds buying those houses. It'll be completely different demographic. But that ventilation system doesn't know that.
No. Yeah. Again, God knows how the ventilation system is going to be working by then, or what it's going to be. And even with the new build example is a really good one, because we also know there's an awful lot of off gassing in the new build phase of a building as well. So it may well be that we have we require a different ventilation rate in the first 2 years of post occupancy than we do at year 10. Because of the way the building is operating. And, with what I've learned about air quality, actually, if I had young children, we also know that that's the foundation for their long-term health and well-being for the rest of their lives. So you might make a different choice to the air quality and ventilation rates you require if you have young children, compared to if you've got robust 18-year-olds, sweating in their room for 48 hours at a time,
hormones raging.
Yeah, God knows. Yeah. So those choices, that capacity and redundancy and flexibility of the spaces, if we genuinely had that choice, building, like you said, if we were genuinely engineering buildings from a health and well-being outcome perspective, they'd be very different looking, I think.
There's a field. Have you had anybody on your podcast that understands epigenetics?
Epigenetics? No, I don't think I do, actually. Not even completely sure what that means.
So genetics is kind of like I guess if you say that it's the hardware of the human body, but epigenetics is like the software. At least that's my understanding, right or wrong. And there was a guy by the name of Dr. Girdle who was studying the transgenerational effect on mice when you did certain things to these mice from an environmental perspective. And it was a great program, and it was called The Ghost in Your Genes. And the message behind it is that you can take a generation, in this case of mice, expose them to something that was an assault on their genetic systems, and it will show up not in the next generation, but the generation following. It skipped a generation. So, and one of the examples of that had to do with, more present day example was when mothers were exposed to diesel fumes while carrying a child, and in the womb. And so what happened is that when those children had children and the next generation were exposed to diesel fumes, they developed asthma, right? So the epigenetics study, and again, this is a field that's just not in my wheelhouse, but it's enough that I wrote Dr. Girdle and I said, after his program Ghost in the Genes, I said, is it possible that when we expose people to, the compounds that come out of outgassing, for example, and if you take a look at synthetic carpets, there's about 30 petrochemical compounds in there. And I said, is it possible that when someone is exposed to these sustained exposures, that it could have an effect, on the generations to follow? And he wrote back and said, absolutely, it's possible. So we need to pull in, not only the neuroscientists, but the epigenetic people, the genetics, about what actually is happening to our genetics when we get exposed to these environments. And
the behavioral scientists and the social scientists and the storytellers and the communicators. And I often say that if when we're doing research or we're trying to figure out problems, if we're not spending nearly as much figuring out how we're going to communicate it, what's the point? Because at the moment, the reason we're not making forward traction often is because we haven't figured out how to communicate this well enough to people. One of the things I meant to ask you was, I get a good sense from you that this holistic view of indoor environmental quality, and we've talked about sound and light and thermal comfort and even things like the microbiome and other things. What does good start to look like in the next kind of 20 to 30 years? Because speaking from experience, it's complex enough even being interested in one field. I'll give you a good example, right? I kept being asked about the well standard, right? And as an air quality person, I said, I probably should do that just to kind of fully understand really where they're coming from with it. And well would be a good example of indoor environmental quality. You know, it's looking at light and sound, the thermal comfort and access to outside spaces and all sorts of things, water. But nothing has made me feel more comfortable than trying to learn things like acoustics and lighting for that flipping exam, because it was a completely new language for me. I had no real, not only did I not understand really the differences between the different acoustic measurements, I had no context to bring to it. So while I could learn the difference between DL and EQ at 3 meters versus reverb something for an exam and pass it, I've got no lived experience of that. As I was saying to the acoustic guy at the beginning of the year, I couldn't tell you what 35 dBA LNAQ feels like. I haven't experienced enough spaces and seen enough numbers to instinctively tell you what's good or bad, right? Whereas with air quality, I've looked through that lens for long enough that I can bring some context and experience to it. So as broad a church as indoor environmental quality is, we've got a really big job on our hands, haven't we? Upskilling, building the knowledge, learning how to impart that knowledge onto the next generation and upskill the sector to take this thing seriously, because it's it's not only broad. Each one of those subjects you could spend your career looking at and still not get to the bottom of.
And that's great points there. You know, a couple of them have to do with the subjective experiences. Like, we can have an intellectual understanding of just about everything, but until you subjectively experience that, your knowledge is somewhat immature. You know, if it's easy for someone to say, well, we can design systems to lower the probability that someone will have an asthmatic response to an indoor environment. As an asthmatic, I can say thank you for doing that. When I have an asthmatic experience due to something in the indoor environments, my experience is going to be a lot different because I'm living my body's response system, right? And we don't want those that are intellectually developing their knowledge to have to experience these types of things. But going back to the neuroscientists, we could hook up architects and engineer students, interior design students, into these laboratories like the Danish Technical University has, or Kansas State, or the Center for the Built Environment, you know, these, and in Toronto too, like all these sort of environmental labs that exist. And we can say, okay, well, we don't want you to have, you know, a long-term negative experience to your sensory systems, but we can show you on a screen how your brain is responding. And we can take someone, we can sit them in a room that has lighting to standards, sound to standards, thermal comfort, all the air quality. So we've met all of the standards that we create, and then we can start to mess with the metrics. Like, that's distort the sounds, that's make the room bright, that's freeze them out. And then on a screen, they can actually see their brains, the neurological signal that's occurring because of the distortion in the environmental conditions. So we're giving them an intellectual experience, but we're also giving them a subjective experience. They can actually see what's happening to their response systems. And maybe that'll give them more empathy for the design process.
Yeah, like every engineering or architectural university should have like an experience lab where you can go into a classroom environment or a bedroom environment or something, and actually we can show you what flicker actually feels like on a surface for an hour, or we can start to mess around with the reverb in a space by introducing different acoustic panels or lowering them or whatever. And actually, now can you see how difficult it is to hear somebody at the other end of the room versus, you know, so you could actually create those experiences for people. I
Yeah,
imagine at a
and
formative age in university, that would be really powerful to say,
totally.
actually,
Yeah.
this is what Kelvin impact on lighting has on a space at this time of day or that time of day, or all of those, because I can read all of that in a well standard or in a SIBSI guide or so
Yeah.
on. Very difficult to make those visceral kind of mental leaps to what does that actually feel like? What does sitting next to a cold surface in a warm room actually feel like? What's the
Yeah.
impact of radiant heat on
Yeah.
me? You know?
Yeah,
Yeah, that's a
totally.
really good idea. There's a
Yeah.
challenge for somebody. Are you aware of anything? I mean, has anybody done that kind of we need to create a theme park for built environment people.
That's
Like you,
brilliant. That's brilliant.
yeah,
Yeah, an
go
environmental
in and
theme
do,
pack. There you go.
yeah.
If you ever
Would it
do
be
that,
amazing?
just give me a call. I'd be happy to participate in that. Yeah. Yeah,
Yeah.
there's individual labs, like there's the QEEG technology. Well, the EEG, there was a paper that was released here recently, I think from students from Australia. I could get this wrong. But anyways, they looked at using EEG. So again, that neurological signal, it was a thermal comfort study, actually. I was just beside myself when I saw it published, because we're starting to see more and more of these technologies being used. Have you had Mark Jackson on?
No.
Oh, okay. So put Mark Jackson on as one of your potential guests. And Mark is, yeah, I have nothing but high praises for Mark. I met him through ASHRAE, I believe, and have watched him participate in the 62.2 ventilation for residential low-rise buildings. And he works for a very large manufacturer. I'm not sure what your policy here is on brand names, but anyways, if you can get a hold of Mark, and what I like about Mark is that Mark's journey includes a very sensitive human structure to his indoor environment and how some of the things that he's done to resolve those things. But he did studies like the EEG, QEEG studies, neurological studies in his journey to try to figure out what was going on with him. And so a theme park, that's brilliant. It really is. And it could be a traveling theme park, just like a traveling circus, or it could be centers around the world, that have these laboratory experiences for students.
Just to show what good looks like, to show what mediocre looks like, to show, I mean, most of us have seen those awful offices with the low ceiling tiles and flickering lights and everything in beige and browns, like, any of us my age and onwards of, the 70s, 80s office spaces could be pretty grim.
Yeah.
But we're not out of the woods yet. And I think, having a space that was dynamic, that you could really send people into and give them experience of, lighting angles and daylighting and access to nature and acoustics and all of these things we talk about, but to make them less theoretical and a little bit more practical. I bet it's doable, actually.
Well, when you're mentioning all of that, and what came to my mind was Bill Browning and Biophilic Design, and Terrapin is a company, and Bill and his crew and those that follow Biophilic Design. I mean, they really look at what you're talking about, like how does the human body respond to the different environmental metrics, and then the changing of those metrics, and the things that they do from an architectural perspective and an interior design perspective, and even from the mechanical side to sort of stimulate positive responses to the indoor environment. Things like, I remember taking a class from him. It was actually at an ASID program many, many years ago, the American Society for Interior Designs, and he was talking about biophilic design and, how stairwells, fire exits or stairwells, how they're, brutalistic, they're concrete, steel. There's nothing attractive about them. People don't want to stop in the stairwells to have exchanges of ideas because they're jail cells, really, elevated jail cells. Well, when they started taking and putting visual stimulation, like they took large screens and had activated images like waterfalls or leaves rustling in the wind or birds flying through a forest. When people met in these spaces, they stopped. and then they started to have dialogue about things that they were working on and trying to identify problems and solutions while one person was going up a flight of stairs and the other one was going down. So it actually brought people together to discuss things that would normally have to happen, in an office setting. But it was just the passing of two ships in an environment that was created that promoted dialogue.
Yeah. No, but you go into this is the thing, we kind of know the extremes. Like, you go into one of these amazing buildings and they are amazing. Like, you see the use of space, the use of light, the use of textures, and like you say, meeting spaces and tiny little comfort spaces we can go and do some work or have a call, or whatever that you can create some amazing buildings. And then we also know the extremes, the other end of the scale. We can all picture them, but it's that big bit in the middle that's the challenge, is how we shift the long tail of the built environment, the rest of those spaces, to somewhere good. That's the big challenge. And back to the kind of the skills and training thing. Yeah, we've got to find a way of getting people competent to be able to measure, assess, and design good spaces, and that you've got well APs and engineers and consultants and so on. There are people about, but it's not just them; it's the entire supply chain. We've got to build some competency in understanding what good looks like. And that's the big, we won't this won't scale. Healthy buildings won't scale until the entire supply chain has got some.
You're bang on. Language. You're absolutely bang on. Yeah. And if you look at the consequences of design through the whole spectrum of participants, I always come back to a statistic that I think it's something like 70%, and I'm talking about North America, and it's probably very true other parts of the world, but roughly 70%, give or take 10% of buildings in North America are under 20,000 square feet. And in this size of building, there's not a mandatory requirement to have professionals involved in the design. Like, you will require an architect and you will require probably a structural engineer. But beyond that, it's not a requirement to have, like in many buildings, not even to have a professional engineer do the mechanical system, because the size and the geometry of the building in our building codes don't demand it. And so the majority of existing buildings today, again, speaking on behalf of North America, there's a high probability that there was no specialists involved in designing the lighting and the mechanical systems. There wasn't a requirement.
I think you're absolutely right. I think that's the global order of things, and they are important. Don't get me wrong. Your Deloitte's headquarters in New York and your LinkedIn headquarters in Dublin and whatever, like these spaces, your McKinsey's and so on. Yeah. Like, it's good to have these real estate leaders that build these great, big, shiny, brilliant things that are the beacons that show the art of the possible, and that's great. But that's not the real world. The real world of the built environment is hundreds upon hundreds upon hundreds of thousands of 5 to, as you say, 20,000 square foot premises that have never had anybody of any real expertise look at them ever. They had an engineer and an architect that had to meet the local codes for how big the toilet had to be and how much square footprint there needed to be in the fire escape area and blah, 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 blah. Yeah. And they were thrown up at cost, at scale, blah, blah, blah. Yeah. And that's the real challenge, but beautifully, that's where the low-hanging fruit is. Like, we can have such a big impact on the built environment with incremental changes in those spaces because they're so poor. Yeah, like, realistic. It's hard to describe how poorly thought through a lot of spaces are, and they're cut and paste specs as well. Like, in the vast majority of the cases. The HVAC system you ended up in one building is the 58th iteration of the same spec that somebody pulled together for a building 10 years ago. And they've just been cut and paste and cut and paste and cut and paste, building after build. And the only real decisions is at the sales teams of the HVAC companies that are competing for that contract at the local level. Nobody's ever really cast an eye over that building and gone, what does the building actually need?
Yeah.
What do the people in that space, what would a good outcome actually look like for that building? That conversation has never happened, ever.
No,
in those spaces. And I think that's a global phenomenon, I think.
Yeah, no, you're absolutely right. You also just triggered another thought, and that things that I've thought about in the past, and that is that the trades in these smaller buildings become the de facto designers. And I have a lot of really good friends that are trade contractors, but I have to remind them that, sizing pipes and ducts and fitting these things into a space is not environmental design. But society puts their faith in the trades in these buildings because of the size. And when they say the word design, their expectations are that these designs, will deliver the environments that they have, which are never defined. No one ever actually sits down with a client and says, tell me your expectations for lighting. Tell me your expectations for sound, right? Or vibration or the thermal experience. Everybody makes an assumption that the designer, right, is going to take that into consideration. But the designers in these smaller buildings, all their design is the mechanics and the lighting. Putting heat into a space and putting moisture into space or taking it out is not thermal comfort design. Thermal comfort design goes way beyond that. And so, society, again, goes back to something you said earlier. Society doesn't understand, it has no concept of what, these environments can be and how you actually get them there. And it's not by putting your faith in the builder. It's not by putting your faith in the trades. You have to put your faith in standards, lighting standards and thermal comfort standards and air quality standards. And again, understanding that these standards take the basics, and elevate them. You can do better than the standards. Codes, and again, so many people, I don't understand why those that are involved in codes, obviously they must be aware of the pressure that practitioners have by designing and building the codes and the crappy outcomes that we get. And, we talked earlier about how do we shift the needle, and codes are one of those ways, but they still to this day represent minimum. But as you know, and we've talked about, minimums become maximums. In a free market world, which we operate in Ireland, the UK, Canada, Japan, the United States, all of these free markets, building codes are how people are judged. And when money is the driving force behind property development, it will never do anything more than is required to get the return on their investment.
How'd you break that cycle?
That is the big question that people like yourself, myself, and all of us that understand how standards work and the research and the science struggle with, because you're facing a political machine that sets the bar low so that everybody can play, and the whole premise behind it is to reduce the probability that someone will get sick. That's what building codes are all about. It's about reducing the probability someone will get sick or injured. But someone experiencing discomfort, which then has an impact on their health, their physiological systems, psychological systems, might affect their learning abilities, their productivities. The code doesn't care. Yeah. So until we find a way socially, like Adam Muggleton, my co-host on the Edifice Complex, he says change comes from the large group, the populations. It's the society saying we've had enough, and they stand up. The BlackBerry phone is a good example where society stopped buying it. They said, we're not buying that crap anymore, right? So the company goes broke. Well, when enough of the population puts up their arms and says, we have a problem, you're our government representatives, as a society, we want this, I don't think we'll see change. We can give all the arguments we want scientifically, from an engineering perspective, from a health perspective, like the health sciences, the building sciences, but until we can get governments to change what building codes represent, I don't know. We'll see the, you brought up some of the buildings, the LinkedIn buildings, the Manitoba Hydro buildings of the world. These buildings are owned by the client. The client owns those real estate. They're not selling it. They're not leasing it. They're not
split incentives. Yeah.
Right.
Yeah.
Those buildings serve that client for the life of how long that business exists. So they have a vested interest to make those good buildings, but that doesn't represent all the buildings in the world. And until codes change, I don't know, Simon. We'll see representation. Someone trying to virtual signal. I've got a well building, and pat you on the back, and you'll get all the certificates and whatnot. But for every one of the well buildings, how many? What would there be? 100,000 buildings that aren't?
Yeah, my hope, I think, because I've wrestled with this for a long time, and I don't think there's an easy answer for the regulation code question. And until you're in a space where you feel that you can not have a code, you'll always need one. In the sense that while you need a floor, a minimum, a bar that stops people putting stuff up that's going to collapse, burst into flames, electrocute somebody, and we laugh, but we only have to point to something like Grenfell in the UK to realize where the construction sector can go if codes and regulations aren't strong enough. That's where we end up, and that's for the really big explosive stuff, that actually where you do get a building burst into flames. For the chronic, long-term, esoteric, nuanced stuff that kills you in 50 years time, good luck. Without codes, you're in trouble right quick. So I think until you don't need them, you need them, in a kind of a weird circular kind of description of it.
Totally.
My hope is, as we move buildings into this performance period where we can actually measure environmental performance, so you start to be measured by the ongoing performance of the spaces that you design, build, or have to manage, that changes the narrative for me, the framing of it, where it becomes less about whether that building was compliant when it handed over. It becomes more about how's it performing on day 722 or 20,055 or whatever it is. And that you then move into the world of kind of the automobile industry, where brands are judged on lifetime fuel efficiency and durability and reliability and design and all of the and long-term value and all of the things that influence the commercial decisions around that sector. A lot of that is born out of the measurability of that product. And that's kind of, buildings have largely escaped that scrutiny, I think, for a long time. We've not been in a position, beyond kind of rudimentary energy management, being able to really monitor indoor environmental quality. But I think that's changing, and changing right quick. And I've been saying it, and I'm going to have to be right at some point, because I've been saying now probably for nearly 10 years that in 10 years, there won't be many spaces you're in that won't be measuring the vast majority of these parameters. So the industry better bloody hurry up, otherwise I'm going to be talking nonsense pretty quickly. But I think genuinely very soon there won't be many spaces that you occupy where some of those measurements aren't being characterized, and then you will be judged. It won't matter whether it was 10 litres a second per person for that meeting room when it was handed over.
Right.
If CO2 levels are constantly going above 2,000 parts per million every time you have a meeting, guess what? That brand that's associated with that HVAC system, that's going to be the only name that anybody's going to be able to find in that space
Yeah.
to blame. And all of a sudden, a manufacturer's reputation will be on the line, or a building's reputation will be on the line. And I think that, and we're already starting to see that. I think in small spaces, we're starting to see people being held accountable by the ongoing performance of the spaces.
Yeah.
And I
There was
think
a
that
time I used
genuinely
to,
changed things.
there was a time, yeah, there was a time when I used to use photographs in my seminars, and I would redact out the brand name of the whatever, the boiler, the pump, the control systems, right? To try to save the manufacturer from the embarrassment of the installation. And then I stopped doing it. And I stopped doing it, and it pissed some of them off. But the point was that if you're allowing this kind of assembly associated with your brand name, then I'm going to show it. Because if you're not going to take charge of it, then you don't care, so then I don't care.
Yeah.
Right. And it was the same thing like with flex duct. Like I used to, when I was producing my drawings, when I was practicing, I retired in 2019, but I had on my drawings, like all of the external static pressure of the system has been designed around hard duct. Flex duct is not allowed. Right. And I did that because when we allowed it on job sites, I had to teach the tradespeople how to properly install it. Well, after 20 jobs of having to do what the manufacturer should be doing, I said, no more. Like, if you're not willing to take responsibility for your own product and how it gets installed, too bad, it's not going to go on my jobs. And we spec'd it out.
Yeah, I think you're absolutely right. Yeah.
We spec'd it out. There were one thing that you were also triggered is that going back to the automobile industry, and people need to understand this, think about this. The way automobiles, transportation has evolved is that today when you get into any modern car, there isn't a cubic centimeter of space or cubic inch of space that isn't useful. They have designed vehicles so well and so reliable, that everything is usable in them. Right. And buildings today, and this actually was triggered by Lloyd Alter from, the tree hugger fame, but now he's out. He's not with tree hugger anymore, and he's doing a fabulous job. Shout out to Lloyd.
Yeah. Everybody likes guy. Lloyd. Yeah. Shout out to Lloyd. Yeah.
Yeah. And we were talking about spaces that get designed, but the building, a good percentage of the building is unusable because it's too bright. It's too cold. For some environmental reason, you can't use that space. And it got me thinking about if you took one office tower in one city block, and you said that, like let's say 20% of the floor area was unusable because of an environmental reason, right? That the capital cost to develop that space was no longer what was budgeted. Like the usable space, instead of whatever, say, $300 a square foot, it's now like $360 a square foot. Well, if you took that logic and you say, okay, well, if that's one office and one office tower, how many offices in that office tower on that city block have spaces that are unusable, and the capital cost and the natural resources that went in to build that are wasted? And then you said, okay, well, how many office buildings are like that in a city? Like how many city blocks are like that? And then you say, well, how many cities are in the province or the state? And how many provinces and states exist in the country? And how many countries? You begin to do a mental inventory about how much money is tied up in building spaces that are unusable and the resources that get mined to build those spaces. And it's like, it's an insult on the human capacity, our intellectual capacity, that we do this. Like, shame on us.
And it talks numbers that real estate understand as well. The Sustainable Energy Authority of Ireland here in Ireland, surprisingly by the name, it's one of the metrics they had for retrofit and refurbishment, under moving towards sustainability and net zero, was the usability of the square footprint of homes. Particularly in homes and particularly in colder climates, what you would find very commonly is that in the harder to heat properties, and we can all picture those cottages where you basically have 2 warm rooms in the entire property, the kitchen, living area, and one of the bedrooms for a lot of properties, and everything else sits at a comfort temperature level that you can afford to heat it.
Yeah.
And actually, if you value that in real estate metrics, the value of refurbishing properties and making the entire footprint of that home comfortable, usable, that has a huge economic value. And
Yeah.
when you quiz people about refurbishment, going back to the residential sector, one of the in the list of things that people comment on post a major refurbishment is how usable the entire property is for the first time in their entire lives.
Yeah.
And it's valued in the top 3 every single time, up against, guess what? Air quality and thermal comfort. So the usability of spaces is an incredibly powerful metric as it goes, but also tied financially into a language that real estate people understand. That how much
totally.
wasted footprint is there in the built environment in totality? Yeah, really interesting. So what's your sense of how we fix that? How we stop this minimum becoming the maximum? Like okay, so Robert's in charge, right? Over the next, get a call from Mr. Trump to get in control of the, God help you, in control of the built environment department, whatever it is. What's the roadmap look like for the built environment to stop the minimum being the maximum? How do we get the built environment into a space where it's valued in a way where we start to unlock its potential?
Yeah, it's not about knowledge and it's not about solutions. We have that. So it's about getting the knowledge and the solutions applying what we know. And that's going to take pressure that has some kind of economic or social consequence. If the SIPCs of the world and the REVAs of the world and the ASHRAEs of the world can demonstrate that there is a societal benefit and an economic benefit to applying the knowledge, the application of what we know, rather than having such a low benchmark, which is what the codes currently represent, then I think we'll be well on our way. But it's getting governments to listen to our organizations. And so the research work, we have to start to demonstrate, the benefits of having better indoor environments. That's got to be one of the solutions.
I think
society, you're right. Society, like people complain, but the complaint has no power, like on a one-off. Like if I buy a home from somebody and I'm not happy with the thermal environment or the air quality sucks or the lighting, it's uncontrollable, whatever the reasons, the sound is terrible, I can complain as one voice to one builder who's building thousands of homes a year. And maybe there's a dozen of us that will complain. We have no power. We have agency, but we have no power. We have no influence. So until there's a collective, there's a couple of organizations, Canadians for Properly Built Homes, Dr. Karen Somerville, that represents, the voice of people that have been wrongly served by the housing industry. And there's another organization in the United States that has that, and I'm sure they exist all over the world. But again, they have some influence, but there needs to be a much larger collective. Governments, and because governments change, the parties change, the politicians change, it's like the weather. And we have to, as a collective, both as scientists, as industry association and institutes, work with society to put pressure on governments to change codes. I'm not sure how else we would do it. I'd be happy to listen to anybody that had any other ideas. That's for sure.
Yeah. Interestingly, when it becomes a consumer protection issue, often there's a lot of power in consumer protection, but we've always operated in the world, like you say, of kind of anecdotal stories where one homeowner or a particularly vociferous WhatsApp group gets together and say, here, look, these homes we bought aren't quite up to muster, Mr. House Builder. And that, if they're noisy enough, they'll often get placated in some way by the house builder. And it's, that's why nothing is ever dealt with in courts when it comes to real estate. It's always settled out of court. There's very little case law as it goes in the built environment. It never gets that far, ever. We don't have these group law cases like you get in the States in English law. So, you very rarely get that kind of community type law approach. But interestingly, where I've seen some traction here, again, goes to performance, where I've seen, because we're now starting to have to say what we're going to do in the built environment, particularly around energy and increasingly indoor environmental quality. Certainly here in Europe, we see it under the Energy Performance of Building directives and Code for Sustainable Homes and various standards that exist. What happens is as people as these monitoring systems, indoor environmental quality monitors, energy monitors, all these things become much more consumer grade and cost effective. All of a sudden, these house builders are now being presented with data to say, here, I bought an A-rated home. The expectation it was going to perform in such a way, and it's clearly nowhere near this. This is a mis-sell sale. And actually, there's a lot of power in that. You have a lot of rights as a consumer not buying the thing that was advertised. And I've seen some fairly major house builders have to backtrack pretty rapidly when presented with big spreadsheets, because even if they're not accurate, or you get your own consultant firm in to dispute it, you're arguing against numbers. You have to have an opinion on it. Whereas before, you could just put it down to that person being a bit of a Karen and, complaining about so-and-so and such and such. Totally. Whereas now you're being presented with files of data that says this objectively isn't performing. And that's a very different world to operate in as a housing provider. And as a CEO of a big developer told me last year, he said, 3 or 4 years ago, as an organization, we got away with vanilla sustainability reports. We'd produce a glossy brochure every year that talked about the gardens and the community and sustainable products that we used in the park bench, and so on and so forth. And that was good enough. Whereas the money organizations, the lending organizations that we're getting the finance from now wants the numbers. They want the details. They need evidence that these buildings are performing in a certain way because of non-financial reporting and GRESB and all of these different standards that are asking for numbers around it. So he says those days are over now. Our buildings have to perform. And again, that changes the narrative slightly. You just don't get away with the glossy brochure anymore.
No, it's very true. I think, if you want to look at possibly where the future goes in terms of change. Like I think here in Canada, an organization like Building Knowledge Canada with Gord Cook and Andy Oding and Mark Rosenberg, and builders like Doug Terry from Terry Homes or Larry Clay from Clay Construction, they're out in the front sort of creating the waves of change. They're applying the building science knowledge and they're sharing that knowledge. They've taken it upon themselves. This isn't government, advancing the science. This is industry advancing the science and builders adopting it and then demonstrating the application of the knowledge and what happens to these buildings relative to the code-built home. And, when I think about Building Science Corporation, Joe Steebrook, and his offspring, that are doing the same thing. Those those organizations, the John Straubs of the world, they're the ones that are sort of tossing the rock into the water, and you're seeing the ripple effect as it builds up. And I think as we see more of the offspring of these individuals and their companies promoting the application, that's part of the engine that drives change. And because when
you see that massificating. So like we've seen here in Ireland, one of the major house builders here adopts the passive house standard at scale, and their argument is we're within a hair's breadth of it anyway, so why not? We've got all of the practices embedded pretty much. It's a very small step to actually be achieving it, and that brings some rigor and quality to the process in addition. But actually it doesn't change fundamentally anything that we're buying, anything that we're doing, and anything that we value. We just have to maybe change some of the processes and the skills around it, but ultimately we can now hit some very high quality building standards. One of the interesting things you mentioned was about the kind of health impacts. I think one of the things that ASHRAE has done in adopting the under 62.2 or 1, I can never remember which one it is, residential one, that's 62.2, isn't it? Yeah. Is the harm intensities of air pollutants. So, the more we start to attach actual epidemiological or harm outcomes to things like air quality, once you have a DALI, a disability adjusted life year impact to it, you can also affix a dollar sign to it. So once you're using these big national level health metrics, all of a sudden you can start attaching dollar signs to these things. So what's the impact of building to code to society versus doing something slightly better? And then you can make some financial decisions. We can actually say, well, look, here's the cost benefit analysis of doing this or not doing this. And again, that changes the frame, I think, because now you can say, well, look, our indoor environment is twice as harmful to us as road traffic deaths and injuries. So how much are we spending on indoor environments?
Yeah.
Nowhere near as much as we are on road safety and traffic safety and so on. So maybe that's money well spent.
Yeah, well, it certainly makes the argument for doing things better. There's no doubt about it. And the reason why I'm grinning is because when I was practicing, we had a kind of a eclectic group of clients, but one of them was in residential. It was all custom houses, and roughly 90% of our 92% of our clients were actually other engineers. And then another 6% were actually from the healthcare profession. So these were physicians, cardiologists, general practitioners. And then another 2% was basically just well-researched individuals, hairdressers, and just sort of that type of profession, right? But these were individuals that were very reflective on their life, and they understood the lives that they were living in, the places that were living. And I always found it amusing that when I took my client base and I compared it to the general population, particularly highly educated, financially successful individuals, and the stupid things that these people do. And and I think back, like these all high-rise, all-glass condominiums, multi-million-dollar buildings, and these individuals had a high probability that they've been into some pretty impressive museums around the world because they had the wherewithal to do it. But they never could connect that when they went into a museum, that the artifacts in those museums were in environmentally controlled conditions. And none of them were exposed to shortwave radiation because that's what degrades the paintings and the woodwork and the carvings. But in their own multi-million-dollar homes that they happily paid for, they'll expose their art collectibles and their musical instruments and the heirlooms that they received from like 4 or 5 generations ago. And they just don't think like why are we doing this to our valuables, but you never see in a museum people doing that shit? Like it's,
No,
so
that's a really interesting perspective. Yeah, that's a really good point. Yeah, just don't join the dots at all.
no, they don't. And
Yeah.
it's not because they don't have the education, and it's not because they don't have the money. It's just that they don't have the capacity to make those connections. So going back to our dialogue here, a part of our challenges is getting the purchaser to make those connections to the things in our life. And we've talked about this several times, on the Edifice Complex podcast, is that if there's anything that the public school system could do right now to improve future generations, it's to teach the students how to buy indoor environments. When you rent an apartment building or a condominium, or you buy your first home or your second home or whatever it is that you are, be aware of what you're getting into. And if you don't like what you see and you don't like what you smell and you don't like the sounds, it's your voice that says, no, I am not going to give you my money to live in this place. That is part of the change process.
Yeah, and I always say to people, it's amazing if you just give yourself a moment to experience the environment that you're in. You'll often pick up those things. Like although we're terrible at seeing the environment deteriorate around us, or, like you say, just it takes quite a shock within a space for us to be snapped out of our kind of existence. But very often going into view places or going in to do an assessment of a space, if you just train yourself to be aware of the environment that you're going into, feel it, smell it, breathe it, sense it, it's amazing how often that internal voice will tell you something's wrong here. You don't have to know what it is, but very often as a human species, I'm not saying you'll always do it. You're never going to pick up radon or CO and all of that aside, but often we'll get a sense. Our nose will tell us, our
trust
our
your
taste
instincts.
will tell us. Trust your instincts. Absolutely.
Yeah.
You mentioned when you were practicing, how's retirement going? Sounds like you're backing off. Or are you really busy? Sucks, does it?
My oldest son, he said to me, Dad, he says, you've done a lot of things well in your life, but you suck at retirement.
Yeah. What did he expect your retirement was going to look like?
Well, it's, you have time to do the things you like to do. And I have a passion, for my interests. And, and the volunteering work with ASHRAE has kept me busy. And working in that sort of educational realm and sharing what I learned as a practitioner over 40 some odd years. I mean, I learned a lot of shit, made a lot of mistakes. That's how that's where the gray hairs came from.
I met Dennis, the current ASHRAE president, and he was saying, it's our job as engineers. I'm not an engineer, so I'm not saying the proverbial job is to pass on that experience. What we don't know in how to operate AI or even the bloody remote to the television, I'm increasingly finding we can bring experience to the table, and that is very valuable.
Yeah. My message to those that'll listen, the younger generation, is that our generation created the problems. We can tell you how we did it really well. We know all the details. We were there.
Ain't that the truth? And boy, did we create some problems.
Right. But we also are not so arrogant that we know the solutions, and because we've had to face them. I mean, they're on our conscience. And I remember once I was giving a lecture, and I was very cynical actually about the industry and where the industry is going. And this guy came up, and he was probably, I'm like pushing him somewhere in the 90 years. And why he came to my lecture, I have no idea, but he was there, and he came up and patiently waited to talk to me after everybody. And he said, Robert, great lecture. He says, and we talked about the the subject matter. And then he said, but I disagree with you on one point. He says, we have to have faith in the next generation of engineers and architects. We have to, know that we've created an educational system and an opportunity to learn and an opportunity to develop experience. And there are some smart kids in school today. And we have to have faith that they will be able to move the needle and move it forward. And his points were valid. I mean, they almost brought a tear to my eye when he was talking to me, because you're right. I mean, it's easy to be a pundit, right? We can sit in the stands and we can be very critical of the things that we've contributed to or the things that we're observing. But there are some really smart kids coming up behind us, and we have to have faith that they can be part of the solution for sure.
Yeah, it's important not to be the two old fellas in the Muppets up in the,
totally,
the stands shouting down at the stage.
Totally. Yeah, totally.
Yeah. Robert, it's been brilliant talking to you this afternoon. I had a whole bunch of questions I never got anywhere near, which I knew was going to happen because it's been a wonderfully meandering conversation with you.
Sure.
I look forward to hopefully catching you in Canada in September at the ASHRAE gig. So
yeah, that's the goal.
You'll be around for that. Yeah, no, perfect. And look, thanks a million. It's been brilliant talking to you this afternoon. I'll put links to your work and the Edifice Complex podcast and all the stuff we've spoken to the show notes. Thanks a million for your time.
Thanks,
appreciate it.
All right. Cheers.
Thanks for listening. Hold on a minute. Before you go and shoot off or onto the next podcast, can I just grab your attention for 1 minute? If you enjoyed this episode and know someone else you think might be interested in this subject, or you think should hear the conversation, please do share it. And let's keep building this amazing community. And this podcast would not be possible without the sponsors: Aico, Aereco, Ultra Protect, Imbiot, 21 Degrees, Farmwood, and Eurovent. They're not here by accident. They care deeply about the subject too, and your support of them helps them support this show and keep it on the road. Please do check them out in the links and at airqualitymatters.net. Also, check out the show on YouTube with video versions of the podcast and more. See you next week.